Hello, can you hear me?
Yes. Okay.
Okay, great. Yeah. So welcome all to this live session. Okay, so uh, I just saw this email just a day back, and sort of it was not a intended MathWorks / live session. So I think the MathWorks live session for neural networks will be on the 19th. So I think there's some confusion, I guess, but we will still nevertheless we will meet today. In general, if you have any questions and things and whatnots about the course and how things are, I would be happy to interact with you. Yeah. So, are there any students here? Students from NPTEL, or is it just NPTEL staff?
Yes, sir.
I have.
Pardon me? I cannot hear clearly. There's some.
I'm having some problem with my headphone.
Who's this?
Velam.
Who's this?
Velam.
I can't hear you well. Sorry. This is PhDCP post 1. I don't know who you are. I don't know. It would be good to turn on your video if you're a student. Okay, you're Velavan. Okay, I see in your post. You're a PhD scholar. Okay. Hello, Velavan. Hi. Can you hear me? Can you hear me, Velavan? Yeah. You can ask any question. Yeah. Okay, great. Please turn on your video too so that we can see your face. No problem. It would be good to have an interactive. Please turn on your videos so that we can see. Yeah, because this is one way that we interact with. We want to see you.
I don't know what happened to my mic.
Okay, there's been some issue. Even for me, some sound settings, I have some issue here. So, but anyway, let's. Mic, mic, you can hear me. Okay, fine. So my system is working, but here it says something is off. Okay, hi. How are you finding the course, day 11?
That's fine.
Things are fine. Assignments are okay. You're able to work out it. Is it helping you understanding concepts, lectures, and things? Are they okay? So where are you? Which part of the which is your you're doing neuromarketing studies at Maher. What is Maher? Manipal, is it? Advanced Higher Education. What is Maher?
Meenakshi Academy of Higher Education Science.
Meenakshi Academy. Okay, where is it? Which part?
It is in Virugambakam. Now you can hear me, sir.
I can hear you. Which part? Which part of Tamil Nadu?
Virugambakam, Chennai.
Huh?
Virugambakam, Chennai. Virugambakam, Chennai. Virugambakam, Chennai, sir.
Virudambakam.
Virugambakam. Chennai.
Chennai. Okay, all right. Yeah. Okay, so you had any questions? So live session, I think somehow there was some confusion between, in the NPTEL team. They had to supposedly MathWorks is on the 19th. Okay, and this they scheduled it for some reason, and it was informed 10. So I would like to just take sort of a just get a feedback about the course, and if you have any questions, more than welcome. So are the notes helpful? NPTEL notes, handwritten notes,
Yes, sir.
are they this thing all that is helpful for the lectures? Clear?
Yes, sir.
Great. And then the videos, when you listen to them, they're all okay, fine?
Everything's fine.
Get it? Huh?
Yes, sir.
Happy.
I need to know a little bit regarding developing my own AI vision models, sir. So I'm interested in that.
Your
Shall I
own?
post that? I will post that in the chat. I will post.
Yeah. Some slurry is hearing is difficult. Something is happening there. So you can, if you can hear me, it is okay. But yeah, type
I
it
can
in.
hear you.
Yeah.
I can hear you clearly.
For me, it's a little bit of slurriness. Post it carefully, and I will read it out for you, and I'll just answer your questions. Anything you want to ask, you can ask. Interested in developing. Okay, here is what you have posted. You're interested in developing your own AI vision model to do advertisement content effectiveness with eye tracking, facial expressions, and implicit association test in one model. I'm facing difficulties in integrating all of them. Okay. So let me give you how perhaps you could build this vision model, advertisement effective content effectiveness with eye tracking. Okay, you want to see if the person is listening app and seeing the screen, possibly, and things, and you want to see the gesture movements and things and whatnots. So this, and then you want to do this tracking, with like these spatiotemporal features. This is because these features are also changing over time, and you want to see if there's attention specific things and stuff. This work, I think, is done. I think you use recurrent networks and things, RNNs and things, because this is best suited for time varying patterns. Okay, and you can there are tools I think you can customize if you did a deep neural networks. So this current course, neural networks, is more a basic foundational course. On top of it, I think because we talk about backpropagation and all of these, it gory details. This is a backbone for deep neural networks. So you can use RNNs and things. So the way you look at it is, when you have this feedback, so it's basically a time pattern, right? You can check if there's an attention, because if you're focusing on the screen and you're latched on, right? It says that you're, so this is, and then these features, if you're drifting somewhere, it sort of, it meanders. So it is more like over time, these features are sort of changing and you can track them. The two ways in which I think you can do this. You can use recurrent networks and you can figure out so you know, for example, by the eye movement, which is a desired signal, you can figure out if this is something which is there is this is attentive, this is an attentive listener, or versus this is this attention span is moving out for some time, and you can come up with these metrics for desired patterns. And the eye tracking, so when you have these windows and things, and once you place the image, when you take this another way is you can extract the portion or the snippet of the image and track the features over these. Okay, let us say you know of course facial expressions is there are multiple things, right? So eyes, in a certain region, if you confine, unlikely this is going to go two-way, right? You can kind of zoom into that window and you can figure out the features that are relevant. That means you're confining the eye movement to a certain zone, which is an attentive speaker, versus sort of drifting somewhere, and sort of it is off over this period of time. So one could use these cues by windowing. It's also part of it's a first is let's an elementary method even before these deep learning models is I take a snapshot of an image and I segment those regions of the images and things that you can segment, right? And these will remain constant, right? Unlike an image where you're looking at that is changing, like in a movie or something, the scene is changing so rapidly, sometimes, right? But still there are some remnants. So you can latch on to the portion of the image, and you can at least make them affine invariant in terms of translations or rotations and things. And so sort of right. Rotations, of course, is an important feature because you don't want your eyes to drift somewhere else, and that indicates you're not listening to, right? So translations, yes, but within a window, you don't want to rotate it like this 180 degrees. You don't want to see the shift. So you can, and then what you do is take the snapshots of the images, extract the features, and you can extract the features. Simple things, you do a PCA on that region, segmented region. Okay, these are some features that you could extract out, and you track those features. Okay, if the angle, because the principal vectors are the same, right? If I take this portion and I extract the PCA, the eigencomponents don't change. But when I rotate and things, you will see variances there, rotations and things. From there, you can put a tolerance band saying that, yeah, did it rotate completely, the person didn't see me, or maybe rotated for just a few seconds and then came back and latched on, because people have different ways of interacting, right? So that way you'll be able to calibrate. And facial expressions. Facial expressions is this lip movements, things are just completely mum, right? Your lips are completely closed, you're not talking. And these days you have a lot of audio intelligence also. And somebody is speaking, you can also bring in that cue when they're interacting. When they're not interacting, yeah, just eye movement. Yeah, if somebody is turned this way, I think this is almost like a 90 degrees shift. And if it drifted by 45 degrees plus and stayed there for a long time, then possibly it is attention drift, or it went up vertically upwards in this direction. So if you're focusing on this direction, you're looking at the angle variation in the principal components that you extracted for the base image. And that's one way I feel you could do this. You are facing difficulty in particularly calibration of real-time screen image, screen size, and my camera time related to my device spec. If you're using Google Media, Pipit has built head rotation and eye gauge and facial expression, but I need to fine tune from Scrap. Scrap is you start with fundamental. You have to have a baseline. Baseline, like let's say you advertise it. You and I are talking, and I say you're available. I'm seeing your eyes available. I'm not seeing the screen somewhere else. I'm seeing your eyes now. Okay, that's my reference. Eye to eye contact, and that position you could calibrate. Okay, that's a baseline. Initially, when somebody interacts, You don't interact like this, right? You're seeing my face now, right? I'm not seeing you now. Now I'm seeing you. Do you see that? So that itself is a calibration. Okay. And how do you calibrate? I extract this image, I obtain a principal component. So the next frame, this is my frame. Okay. The vectors are the same, but their orientation has changed relatively. The moment you sense the angle between the vectors, let us say the PCA gave you vector v1, v2, v3 at time t1, and I got v1, v2, v3 rotated by something at time t2, I can figure out the angle between them corresponding to them because the phase has not changed. Correct? Relative to this frame, only the rotation has happened. From there, you can build the thing. Okay? And this is how we do our fingerprinting calibration also. Right? If you look at the fingerprinting calibration in the iPad, what it is doing is you have a machine. It says you first place it like this, place it like that, place it like that. Right? And that itself is telling you the base truth. And then as you start rotating, it is looking at features which, even if you rotate it, they're invariant. So this is the simplest example of principal component analysis that you can do in a very easy way using your angle metric. Okay? You don't have to sophisticate with RNN. But these days, there is a very fancy thing that people like to use RNNs and built-in modules, and you can just plug in, and if that helps you. Okay. Yeah.
Can you able to hear me now?
I can hear you. Yeah.
Sir, actually, I'm just want to implement MOR, sir, a mixture of recursion unit in my
Measure of what?
project. MOR, sir.
Reconstruction.
1 minute.
Yeah, please type it out carefully, please. Maybe if you had a headset, that might also help in case. Yeah.
Yes, sir. Yes, sir.
Mixture of regression model to overcome system inefficiency. I don't know how to implement that in my device. All the process I'm trying to do is Google AI audio with prompt only. Um, mixture of recursion model. Um, okay, so what is the
Yes,
specific
sir.
thing that you have in? See, I have not played with Google AI Studio. Frankly, I do not. Maybe you should check with the TA or someone who has. I have not played with this. I don't know how to implement that in my mixture of recursion model. Can you give a little more specific on this mixture of recursion model? I do not know what this is. Mixture of recursion.
Actually, sir, the mixture of expert model is there
A mixture of
for
experts, I
intelligent
know,
AI.
because multiple experts will comment. What is this mixture of recursion?
Recently, 6 months back, Google has published that it has done a major breakthrough in AI model predictions over 6,000 times better than MOEs using
Mixture of experts. Okay. Yeah.
okay, recursion unit. Actually, it is paying way for deeper analysis, um, uh, whatever the need for calculating a high-end work, it is allocating the space for the particular domain and lesser uh, memory utility for lesser
So what is it you wanted to do
calculation.
this mixture of recursion model for? I mean, what is the application you are targeting to use this
Actually,
for?
my device has like an inconsistency of only being 8 GB RAM, so it cannot do high-end calculation in the real time while processing the video. So what I'm trying to do is first I try to download the videos using Cambrax from the background and
Yeah.
collect all the eye coordinates and facial expression as a single frames of video. Then I'm trying to plan to connect with the cloud and do the all
Hmm.
sort of
Yeah.
analysis.
Cloud is a better solution
I can,
because there at least, yeah, you are able to access cloud and be able to do that. Those computations in
yes, sir.
the RAM and other, because there you are not worried about the system specifications on the cloud, right? Yeah, you had
Yes,
these
sir.
issues.
While doing that one, due to network latency, I'm feeling a lot of problem that many of the times whatever the predictions coming out, it is not up to the market. So it is not crossing more than 40% efficiency also. So what I'm trying to do is in my own device, trying to implement my own vision model so that it can execute in a very efficient way of task needed, which is having a high priority, more time and
For
less
this
priority.
specific problem, right? For this
Yes,
camera frame, blah blah blah. I said you
yes.
make the model simple. You don't have to use Google AI. Of course, if they're solving it for you, it is good to make use of it. So here is what I would do. First, I would think rationally how in a low-cost solution. For example, I give you this PCA idea, right? So you must be convinced, and around it, you may be able to develop certain things because you have the frames captured, and let's say you're able to segment the regions carefully. From there, you can extract the PCA parameters. And from PCA parameters, you can possibly, it's just this much that you want to track and just you want to kind of do this. You could bring in some metrics post, like for example, looking at variances around that, sort of changes from the PCAs, those vectors. You can figure out some low cost solutions that can work, and if it is solving your problem with high precision, great. But for some reason you say that this any other method specific to this particular problem, you say that yeah, there is a built-in software and built-in routine that you
What
could
are the
type.
solutions?
Yeah, you you may have to
What
strengthen.
are the solution? What are the solution available, sir, currently? Most of them are paid versions only.
Most of them are.
Paid versions available. Otherwise, we are giving for a trial for 1 month and we are closing,
I mean,
pushing us to
you
pay.
define the solution. You come up with the algorithms. That's a simple. That's the easiest way. That's the reason why I said if it is paid version and there are certain things, you don't have to do that. You come up with a low cost. You frame it. Frames are no problem. You can capture it, and you can once you have the frames, depending on the RAM, of course you should be clever to do your processing very intelligently. Where once you extract the features, whatever is required, you keep it, and then over that you're relatively able to look at only the differential with respect to that. Only track the differential. Okay, exclude the rest of the things and treat them as background. And only those regions where you want to focus on those segments of those images. Right. In this case, it's just not just eye movement and possibly this portion here, this facial part. Right. You have to extract those features over those local features, and then look at the changes with respect to the features you have extracted from. That can be done pretty much with low cost signal processing. No big deal. No big deal. Is a you could do that. It's not hard. All you have to get samples, and you can just do signal like the way I described to you, the signal processing, and then you have to estimate also. Sometimes to be clever when you design algorithms, you have to estimate what is the complexity, right? When you're running some solution, what is the space complexity, what is the time complexity? You have to estimate that, correct? There is always some trade-offs between the space and time complexities. Okay, so you should know how much of memory and requirement. Suppose you are running something and it's out of memory, obviously you'll be struggling. You have to strengthen up that much. Or else you see if you can make it sequential. if you don't want to paralyze things. Then you can use it in limited storage requirements, but then you will have to buffer them and still hold, still it has to be there in the in the RAM or wherever it is. You should have, if you're buffering it, still it's going to be in the RAM somewhere. Yeah, I think that's how I would imagine. Um, right, and then you can compute it. Yeah, either way, you have to first strengthen out how much of memory requirements you have at runtime, at buffering, how much ever it is, and then process it. If you're doing in parallel, yes, all of that space would be used in the RAM. Otherwise, if you're doing it sequentially, taking any differential changes, so you have to do the calculations. It's like, I tell you, this is the same thing as how you build a home. You don't say that, I don't, I know I need to build this many square foot and then I'm short of bricks or something like that. You have to estimate, come up with an estimate. And from that estimate, you work out and you have a class of algorithms. Right? And this you think within this frame how I could do this. And I give you a few ideas to go through and do your literature survey, figure out what is the state of the art and see if it solves your problem in the low complexity wise. If it does it, take it. That's it. Okay. Does it solve your problem? Does it help? You have to
I will.
implement it. Only when you try it, you will know. I'm only giving you
Okay.
suggestions. I'm telling you things, but this is how I would have done it if I were to. I would start with these features. I would figure this out and then work through it. But yeah, of course, if they're plugin modules, yeah, you have to pay something for them because yeah, these are not this thing, and or you have to have some ways to if there's a freeware you can try. But I always suggest part of this course is you learn through all algorithmics. That's what it is about. Is in neural networks. You know, there's a lot of math, lot of first principles type of thing. So you try to map it to that problem and see could these ideas work. Okay, and only when you try it, you will know. You have to try it, and you'll try it. You will see. You have to, I think I teach PCA there. I also talk about all of that. I teach there. Hebbian, uh, this is kernel based PCA and things. I teach that in the towards the end of the course. What I'm talking is not even kernel based, but simple PCA that you can try
Okay.
on this. Okay, that should help.
Okay.
And yeah, hope that helps. Then you can use some plugin modules for those. Yeah. Okay. Anything else? Is it clear? Some ideas I gave you. So many things you people should try above and beyond. I mean, course-wise, we give you techniques and tools and how to go about it. So the best way to learn any topic is when you actually encounter the problem. When you see the problem, of course, you have a feel. The theory and all learned in the class will give you an idea how to approach it. But when you start imagining and start doing things, then you will realize the power of some of these algorithms and things and what you could do. So try above and beyond that. Yeah, real time system is not easy. You have to be mindful of all of these constraints. So I see Rahil Saini had logged in. I know who you are. Can you turn on your video, please, if you have any questions? So please turn on your videos, please, because I can see your faces. I have time series data of acoustic signal, which is non-stationary signal. Okay. My question is how to apply neural network in my case and which type of feature can be extracted by this type of signals. Okay. acoustic signal, which is I wouldn't say it's non-stationary, it is quasi-stationary. So I don't know who is Anand Kumar here on YouTube, but I don't know. Okay, so I'm just, I don't know about those, but let me answer you. Try to answer your question. So neural nets are those. Okay, it's a good question. So now, when you think about learning data point densities, where it's not a process per se. It's a good way for these type of models for non-stationary is even like have uh, predictive filters which you have these slices over time. Okay, so I let me first explain to you about this non-stationary part, and then we'll come to how you could process this data. So you have a time series data, and you're taking the window of that, some finite window you take, and on the window you compute these statistics. Statistics is everything, all the moments and things, whatever you want to compute, and you take this window and maybe you slide it and you just go over maybe over some portion of the sliding the window. This data is statistics is almost the same, but if you go a little far away, the statistics are going to change. Statistics is your mean, all your moments, right? Of course, moments. Yeah, mean is the first moment, first order moment, and all your moments are going to change. So first, I want you to first examine that. Okay, what are the moments and what is it that you're interested in, and things. First, confirm and affirm to what level of degree you have this non-stationarity. Next, so in neural network, what happens is there are two things. If you normally when we deal with stationary data, you are only dealing with data point densities, in the sense that these the PDF is not dealing with the process. So therefore, when you have the statistics and adjust the parameters of the model, the weights are fixed, because for that particular statistics, the weights are fixed. Now, what happens is with these models, if you were to look at different predictors for different situations of the acoustic signal for whatever, you may land up with banks of filters or banks of filters that may have to change with time. So you can also it's like a filter bank sort of, but a non-linear set of filter banks. So imagine you have a set of weights. You see my hand, right? This is much easier. So you imagine this is one set of filters which correspond to a particular statistics. We have another bank of filters that you have adapt for another set of statistics, another bank of filters. So imagine like this. So if you knew, the statistics, you can have these weight parameters which are tuned or attuned to a certain data statistics. In that sense, you can sort of visualize this network, this neural network now has sort of like you're bringing in the time variable across, where you figure out that these parameters are going to change, or you have a huge network and you have a desired signal, you bury everything into that model and the beast is going to solve it for you because it is just a huge network. But let's say you want to be a little more clever and you want to kind of figure out, okay, I know for this particular statistics, I've fine-tuned it very well, and this model is giving me 99%. Then okay, start another bank of filters and say, okay, these conditions have changed, and I'm going to trigger these filters if I see this onset. And this triggering onset you can figure out, and that's one other approach that you could adopt to solving this problem. Or you can just go the vanilla type of, with the time-based networks, like, they have this recurrent type of feedback. So you're bringing in a time delay to the models, and because of the time delay, statistics are going to change. Here, non-stationary means signal frequency changes. Yeah, I don't care. Signal frequency changes. That means your statistics are going to change. Your statistics are going to change. That's it. Your frequency change. You're computing of course, when you take a window, within the window, you can take the, frequency changes in your time, you look at a pattern in the time window. that is also a change, right? You will see the patterns. For example, how do I put it? It's just not a frequency change, but the time window being the same. The frequency changes, and along with this is also the same. In the window, if I take Fourier transform, I can extract any features I want to. I can extract autocorrelations and moments and things, and I can figure out those changes, or I could even extract the spectral coefficients over these. Okay, so if the spectral, if I take the transforms, Fourier transform of this short term Fourier transform of this, and I can figure out the frequency changes. I can figure out that something is off. I can sense this. Correct? I can sense these changes, and then I have a model which is going to adapt to these changes. Okay, so this is how I could figure this out. So I can have a neural net where the weights will adapt to this, and this is part of it. I mean, and you don't even need to have a complicated neural network. You can just bring in an adaptive filter for doing this. It's no big deal. Okay, adaptive filters are even more suited for these type of problems. But you may have to have a bank of adaptive filters if you see that you require them to track, or you can let's say there's small changes, so the weights will change. You have a predictor which is going to change the weights according to the stimulus, and then therefore you can track this. So it's a time series. This is an adaptive filter setup here. But if you want to build a neural network, so again, as I told you, the two ways. One, the statistics. You want to say that I want to just have a whole lot of data point density that I have, and I want to say that this PDF is the same, and with respect to that, I have a set of weights which are going to be representing that density, data point density, and because statistics are changing, I want a new set of weight vectors which I can have as another slice, and this would respond to that stimulus. So in that sense, you can bring in this filter bank approach to your neural networks, which is going to respond to these changes. And you can sense the changes by computing the statistics. Statistics can be anything. It can be just on the time window, or you can go to the transform domain. You can kind of compute the spectral, do the FFT of that, extract whatever you want, and you sense that this is changed. And because of the changes, you trigger. And then you have to collect the density, because it is one observation you see, right? And you have multiple such observations for such signals, because you're reading this from the sensors or reading from different snapshots of the signals, right? Then you may want to look at all those patterns that correspond to that regime change of the region change of where this non-stationary kicks in, according to your data statistics, and then you can build a model. Hope this clears. Okay, so based on the tools that you had, you can build this up. Is that clear? Who is this? Anand Kumar has asked this question, or Rahil? Who asked this question? NPTEL IDC.
Anand Kumar asked this on YouTube, I think.
Okay. Okay, I don't know who it was. Anand Kumar is a student here, for the NPTEL student.
Yes, I think he's taking up neural networks course.
I hope this addressed your question, because I don't see your face. It's important that the person who is a learner, please, it's time for you to interact. You pose a question, and I want it to be as interactive in the sense you should be convinced about what it is. Because otherwise, I can imagine and I can tell you what I feel, but you may have a specific question in your mind. Which Anand, I don't know whether you're hearing me or whether you're logged in, but I hope this addresses your question. Okay, if it addressed, please at least acknowledge with a thumbs up that at least I know that it has addressed your question. If not, you can pose it in a different way that I understand your question, that I can address it. Okay. Rahil, where are you from?
I'm from Jammu and Kashmir. Right.
Nice. Which part? Which part of Jammu Kashmir?
Jammu part of Jammu and Kashmir.
In Jammu or
The
Kashmir?
city, the
Huh?
city of Jammu.
City of Jammu. How are you finding the course and things?
Uh, it's nice. At first, I was unable to understand most of the things, but slowly, with weeks coming over, I finally have. Um, Finally, I'm trying to understand what's going on with the course. I actually took up thinking that it will be related to machine learning and implementing it through code, but it was mostly mathematics. So that is what was different.
Okay. No, I think yeah, we have to, because there will be some live sessions through MATLAB. Okay, and that's the intent is you're gonna you have first live session on the 19th. So they will tell you how to, part of it is a theory because you otherwise we should have a complete math course, but there's a separate course altogether. And this was introduced to basically give you the foundations of how backpropagation works, or how the radial basis function works, what is the XOR problem, how the SVM works, give you the whole feel of neural nets, right? Starting from perceptron all the way to all of these, because the backpropagation algorithm and these are, bare building bones for deep neural nets and stuff. So I think that was the purpose of this course. Okay, but now, having gotten a complete feel of the mathematics, you can now explore tools, how to build these, code it up, and things. It's up to you through data sets and stuff like that. If you are at ISC, we would do this. As part of this course, you would be doing this as part of software exercises that you would be coding up for in homework exercises. But in NPTEL, we cannot do that in a mass way because we have to auto grade. We have to figure out a way to auto grade all the homeworks and things. But you could please provide us this feedback. We'll think about it and see if there are ways in which we can make it. Yeah, because this course is on the math side, but assuming that you build on this for projects and things that you can work on the assignments.
I think it's good because it's building up. It's something that we are using our critical thinking. So
Yeah,
less of courses in semester. So critical thinking was something that used to happen in semester 1 and 2 in my course, which I'm taking up in my university right now.
yeah.
So currently I'm in 7th semester. So the courses are
You are
mostly
in
coding
BTech,
based.
right?
So
You're BTech in IT
the
Jammu
critical
or
thinking
BTech?
part just
Huh?
I'm
In
doing
IT?
it in Sri Mata Vaishno Devi University.
Srinagar, okay.
Sri Mata Vaishno Devi University.
Vaishno Devi Mata University. Okay, got it.
Yes, sir.
So you're a BTech student, is it?
Yes, sir, I'm a BTech student.
Okay. This will give you the foundations
Right.
of how to approach neural nets and things, and what are the bare bones
I
within
think I had skipped the mathematics part earlier. Like the things you are teaching now, I have studied it in my last semester, but I didn't know that there's quite a lot of mathematics behind it too.
it is all nonlinear signal processing. So there is quite a lot of that. Once you know, because the purpose is, if you were to build your own algorithms, build your own this thing, this is going to help you to make you think in that direction, right? Otherwise, right now there are so many tools available. You just plug and play modules. You just give the data. You just run the module. It will give the results for you. That's not the purpose of this course. This course is
Right.
to give you the foundations from where you can kind of build upon for, let us say, deep neural nets and things like this. Okay, this is like a bare bones level 1 course in neural nets.
Yes, sir. So what else can we expect in our coming weeks?
It will just follow the list there, right? You have a list of all everything. Where are you right now? Did you cover SVMs?
Yes, we just started with week 8.
Week 8, let me just see here. Week 8.
It was
Optimal hyperplane for linearly separable patterns. Yeah, I think all of that. Still SVMs and stuff. So you're gonna, at least you get a feel for that. And you learn how you can adjust your hyperplane based upon these loss functions and things, and yeah, so those are the details will be covered. And because this whole idea about SVMs is, that you could go with linear separability. And where do you want to go with linear separability? Because you could kind of you can go to higher dimensions. And this is where all of these things, how do you take kernels and lift them into higher dimensional space? Because patterns may not be separable in a lower dimensional space, and you want to lift these patterns to a higher dimensional space and then figure out linear classifiers for those. And that's the whole idea. And I think you're going to learn all of those in that. So there are, I think, nice examples. I think I don't remember.
Yes.
I'm seeing this after 5 or 6 years. Frankly, I have interacted with NPTEL students in, I don't know, at least 5-6 years back. Sort of, yeah. I don't remember every weekly wise content, but I just, I searched on my page, what is it on week 8? So, yeah. So,
yeah, the videos are posted 6 years ago.
Huh?
The videos are posted 6 years
Yes,
ago.
6 years ago. Yes, it was before COVID. I did this 6 years back. So you're right. I have not taught that course after that. It has been a long time. Long time. Yeah. But yeah, so you get a picture of that, right? You get an idea about SVMs and things.
Yes, sir.
This idea about this is linear classifiers you want to build, and and then how to go to higher dimensions through kernels. You go to higher dimensions, and there you figure out patterns. You can separate them. So they go back. Is it clear, Rahil?
Yes, sir, it's clear.
So again, I saw something in the chat box. You mean first I have to apply wavelet or STFT? Okay. So don't confuse wavelets and STFT. Wavelets treat signals as such. You're not going to do any windowing and any of these sorts for wavelets. So wavelet transforms are so STFT for STFT you do like you do take a window. On the window you are going to apply the Fourier transform. You apply a window. Window is not necessarily a rectangular window, but having whatever, it kind of figure out a good window. And the window you apply the Fourier transform and you extract coefficients, and then from there you feed this intelligence to the neural network to adjust its weights. Wavelets, you don't do the windowing. It defeats the whole purpose if you do the wavelets. So wavelets, it's based on this MRA, multi-resolution analysis. You have to take the entire signal as such, and it's okay. Wavelets work for these. So you do the wavelet decomposition of the signal, and across scales, right? You can go to whatever level that you working in BARC. My signals enrolled this neural nets times. Okay. Anand, could you please log in? I would like to see your face, please. You work at BARC, so okay, fine. Please, you could log in live. I'm here live. Request NPTEL folks. If you don't have the access to the login, you can request NPTEL team live. They can provide you with the login and passcode, and you can log in live. I can see your face and I can interact. So yeah, it's much easier. Yes, you could. Yeah, wavelets. You process the signal as such completely, right? And then you can extract the wavelet coefficients. The wavelet coefficients at different levels of the scales. This gives you, when you go to that dimension in the signal space, you can figure out what are those coefficients and things like this, and you can kind of figure this out. But now, if you want to extract the wavelet features and take these wavelet features and feed this into a neural net, you could also do that. Because when you have extracted features, the features go to your front end, that is the input of the neural net, and then you have a desired response, right? So this signal is maybe something, this signal is something else. So you can bring in that intelligence. There is sort of, in that sense, you have these features and you're mapping the input space to your desired response. And let us say you want to use whatever deep network that you want to do, and it's all oblivious, since you don't have to worry about everything. the network will do it for you. Okay, the deep network will do it for you if you make it complex. But let's say, Anand, you want to kind of have more control. In the sense, I want to know this particular zone. I want to be very, very precise. I want to be able to control from my window. I extract the parameters, and the parameters, I know exactly that, yes, I get a whole bunch of these statistics, and from this I want to control that micro detail. In the sense, I want to know how exactly my 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 weights and things respond to this window and the slicing and things. Then you can follow the other approach I discussed with you. Okay, that means you have a bank, and you to the bank, you tune the filters, and then you have complete control that if you have just finite sort of regimes that you want to kind of figure out, you can say, yes, these bank of filters are extremely tuned set of things, tuned set of weights for this particular data, and then through signal intelligence you can garner what regime, what region you are in, and then apply and predict whatever you want to. Okay, so this should help you. But if you want to do it in a more fancy way, I don't even care about all of these micro details. I just extract the features, feed this into this beast, to this neural network. You can still do it. It works. Yeah, including warp data and things. But often I feel than just bluntly feeding it into a neural network, my own feel is it will be good if you can kind of bring in some intelligence to it, in the sense you kind of do some processing, check if the patterns are to be warped or things and whatnots, because you have a complete control of the data. Okay, and the neural network is either a classifier or a regressor or whatever its job it is doing. But I suggest that you go with the signal processing approach to extract as much intelligence as you want to from that data, and then feed that intelligence to the network, than just in a dummy way just feed because you have a lot of compute resources, just feed that data into a big network. And just that also works, because the neural network is also doing that in general, because it is kind of it's oblivious, it's doing all of that. But I feel for sensitive applications or things that you want to have micro do things, you better do signal processing first, and then extract the parameters, extract the features. Then you feed this to neural nets, and then build your own neural network for that. That 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 gives you really the high accuracy that you want to. I hope I am able to answer your question, Anand Kumar. Yeah. And if I answered, it's okay. If you don't, it's just if you have anything very specific, I suggest you write to me or come to ISC if you're close by. You can always discuss. And how are you finding the course, Rahil and Anand? Is it okay? Sort of the assignments and things are challenging. You're learning through things.
The assignments are quite challenging. I think the week 7 was easier than week 6, and even week 5 was quite hard. But because in week 7 we had basic things like what exactly is complex functions. I have studied it in my semester second, long time ago, so I didn't knew what was convex functions.
Okay.
So I had to revise it again, going on YouTube, and so these basic things. But otherwise, it's something that we can do. It's doable.
That's good. That's good. And also, the notes and things are helpful. Lecture notes and handwritten notes and things that are there in NPTEL. Is it useful, helpful to all of you?
Yes, sir. Sometimes when, let's say, we can't watch the videos, like we skip the week and we are doing the assignment on last day of submission. So that's when the notes actually come in handy. But otherwise, I think videos are better because you are adding up extra things, speaking extra things that are not written in the notes also.
Yeah. Good.
So there was this thing in support vector machines, convex optimization. So how is it different from concave optimization? Is there something like
You
concave
just put
optimization?
negative, put negation, that's it. Convex, concave is the same thing. Something like this, something like this. Sometimes they say convex up, down, convex up. Doesn't matter. So if you're looking for minima on this, if you flip it, it's like looking for the maxima of that, negate it, that's it. So concave or convex families are the same, sort of. Nothing to worry. Okay, it's just a negation. But non-convex is different because with convexity, what happens is, see, what do you mean by convex? So what do you mean is concave or this is a convex? I always think about this lens analogy, right?
Right.
This is a convex lens. Okay, something of this form, a function, is convex. And the other way is concave. Concave is this like this. So it's hollow surface, sort of. So you have, it's just the same analogy. And if you're looking at whether you want to minimize or maximize, you just negate it and just work it out. The same thing, same idea. The good part about these convex functions or concave functions is you can use gradient descent because you have a saddle point which is unique. You can just kind of get to that. So that helps you whether you're doing ascent or descent. Okay, so that's the good part about these techniques, and this will not carry forward for non-convex.
Right.
Yeah. That's why people like quadratic cos, right? X transpose AX and there's form quadratic functions and quadratic type of parabola is a nice thing. This is a nice saddle point. So of parabola, I have like a, I don't know, your Himalayan turf, which goes with many ridges and valleys, like a Kashmir valley, goes up, down, blah, blah, blah. So and if you want to look at the minimum point, you cannot because the local minima is difficult to get. Local minima is okay, you can compute, but global you don't know because you have to kind of go up hill, come down. You don't know where the actual true value is. And in general, the search for global minima is hard. You can't. Okay, there are only ways like annealing and things and ways you can overcome this. So therefore, need to make life easy to set up convex functions and solve it because it's mathematically tractable. But sometimes in engineering or sciences or wherever it is, you may require just you're given the problem. It's not convex. They want you to figure out minimum or maximum. Then you have to come up with other techniques. Maybe at least you can come up with a local solution which is within some tolerance. You're okay with it.
Right. So let's say I have to implement something like this practically through Arduino, for example. How exactly are we speaking in terms? Let's say I'm using a Arduino and I'm using a sensor connector to Arduino, transmitting the signal. So how can I implement machine learning in this case?
So well, training you will not be able to do this. The inference is okay. This is where these boards are helpful. So first you can train the network and things on cloud or whichever platform or server or wherever you can train, where you have resources, compute resources to this. Okay, and once you have trained and learned all the weights you can put them onto the board, and then this is just an inference problem. That is, you're extracting features or whatever it is that is required for the algorithm to work. Then you do the inference on it. That is the testing set. You test it based on the weights, and you get the values, and it becomes very fast for And in case things change, then you have to have some connection between this wirelessly to kind of take the data. Say you do some differential learning or whatever it is to upgrade some weights and things based on some new statistics that you have, download the weights and have this. So this is the way I think hardware solutions should be working, because you don't have too much of data memory and program memory and things on handheld devices for you to do everything, or Arduino, this sort of things, unless you have that much memory. If not, you basically that's the reason why in neural nets you're not going to have training on the device. You don't do that. Okay, you do it somewhere else. Take the weights, put them on to your system, your hardware system. Inference is very fast. Use a piece of hardware, right? You don't have to do all the multiplications and things like this. Hardware, you can just quickly execute it. It's very fast. Does it help? Ahil?
Yes.
Hmm?
Yes. Actually, I just
Or if you're
wanted
doing,
actually, my question was something like this. I couldn't put it in right way. It was something like this: ki I'm implementing a machine learning model on a data or where two sensors are involved,
yeah.
and Arduino is doing all the computation.
Mhm.
So two sensors and two Arduinos, and there is signal being transmitted and received
Yeah.
from
Okay.
both ends.
Yeah.
So machine learning model we are implementing, is it just the data we are implementing it on, or we are also implementing it on the sinusoidal representations of signals?
Signals, you don't care. It's data. When it comes to neural network, it's just data. That's it. You're sampling it. You're just having digital data. That's it. Okay. You're not worried about analog signals. It's post sampling, all of that. It's just some data, some numbers that you get from there. Okay.
The
that would be your input to the neural net. Okay.
Right.
So the reason I'm saying is because if you want to do some inference, it is much easier to do inference on the thing, because training, etc., you can do it in software. But there are also engines. For example, if you were to look at FPGA arrays that you want to use them for learning or hardware-based learning, because say software is because you can parallelize, you can do many things. Sometimes you may also want to do the training on the hardware. But that is a different problem altogether. That means if say you want to force, I want to do this training on the hardware, you have to have huge kind of resources for doing all the training. And it's application specific. But then that hardware is going to be not so useful. But it's going to be a dedicated piece of hardware for just doing the training, no matter what. Right. And the moment you do the hardware, you can't just customize for everything. It's sort of, you have to have some constructs for that. So my suggestion is, if it is simple inferences problems, for example, like, I want to figure out some classifications directly on the fly on some edge device using some boards and things I want to do. Just extract the data, feed it, learn the parameters, take the weights, burn it onto the engine, onto the hardware, or the FPGA board, or whatever it is, Arduino board, or whatever it is, and then do the inference. That's it. It's very easy. But for some reason, your data changes. Take the data, redo the differential learning, download the parameters back, and kind of, ensure that it's also there so that you're able to recognize new patterns as they come along. Okay, that's a way to go. But if you are hell bent on having a hardware for training, that's your application. Then you have to build an engine to do all of this algorithm on a piece of hardware. Clear? Yeah. Does it address your question? So don't worry about the signal and all. You do the sampling, quantization, everything, and this bunch of numbers you get. From the numbers, you can extract features or whatever it is required, feed that data to the neural net. Okay?
Right, sir. Yes.
Yeah. So I think it's 5 minutes past 4, and our timing was 3 to 4, and I hope we just had 3 participants. We need to see more, hopefully, next time. And if you require any sessions like this with instructor and or the TS, please request NPTEL. Okay, we can meet. I'm happy to interact with you 3 times or 4 times. I don't mind. So let us. If you have questions, any questions you can ask. No problem. Okay, that's pretty much it. So maybe you're halfway through the course, right? You still have another 6 weeks, correct? So wish all the best with your assignments and things, and stay tuned for the MATLAB live sessions, because you may get exposed to certain toolboxes and things, and this will be very helpful for you, particularly if you're trying to do any projects and things stuff. Okay, so if there are no questions, I think we can take leave. NPTEL, I don't see anything in the chat box here.
No, sir.
That's
Not
all
from
it is.
NPTEL.
So we hopefully want to see more people. Please, All right. See you all. Yeah. Have a good week. Bye.